Hey guys, this is Wojtek, and today we're going to continue our fundamental series talking about C++ interfaces, and specifically how they are available to us within the Unreal Engine, how we can determine if our objects inherit them, and how we can assign them to pre-existing actors within our world. So, without further ado, let's get started. Alright folks, so to begin we're going to create our interface class. And doing that just through the editor by going to New C++ class, scrolling all the way down, where we'll find the Unreal Interface object definition. So just click Next, and we're going to call this our interactive actor. And essentially this interface is going to allow all of our future actors to implement a method of interact, and then, wonderful things are going to happen when we execute that. So let's go ahead and create this interface. Alright, so there's our interactive actor interface, and we're also going to create a new class that is going to represent our interactive actor. So in this particular case, we're just going to create our base actor class, and we're just going to drop it into our props folder. So we're going to call this guy our interactive prop. And again, it's going to just take a little second, and I'm going to create this class. Okay, and there is our interactive prop. Now, just before we get too far ahead, I'm just going to quickly reorganize this folder structure a bit. So we're going to move our destructible props into their own folder, our physics props into another folder, and then we're going to create a new folder for our interactive props. So let me just move over this junk. And there's our physics. And why would I move it into the correct folder? There we go, much better. Okay, so now that we have our interactive prop, we're just going to create a new blueprint just so it's there. And then we don't have to think about that later. So we're just going to find our interactive prop class, select, and it's going to be VP interactive prop. All right, cool. So we're going to save this. Actually, save all of this. And we're going to switch over to Visual Studio. And you'll notice within our source definition, we now have our interactive prop as well as our interactive actor interface. So let's take a look at this thing. And if we look at the CPP file, you'll notice it's quite barren. There's not really anything going on here because the majority of the work happens in the header. And essentially what Unreal is doing is it's using this empty class, which they reference to as an interface, as a way for their reflection mechanics within their engine to basically process these classes as if they were interfaces. So folks coming in from the world of Java, C# or any other sort of language, you will realize that this does come with an actual implementation file, but it's not super necessary. So now, how do we actually go about defining an interface method? So very similar to how we handle, oh my goodness, use function. How we handle our regular method definitions. So we're going to annotate it with the, or decorate it with the use function call. We're going to make it blueprint callable. And we're going to also make it a native event of a category interact. And this is just going to be a simple interact function. So it's a void, no parameters going in, and that's kind of it. This, carried down now through our object definitions, is going to basically expect any class that includes this interface to implement and override the interact method. So it just happens that we have this lovely interactive prop. So let's go ahead and attach the interactive actor interface to our prop. And then we do that is, as part of your class definition, you're going to say public interactive actor. Now you'll notice my resharper is being helpful, and it's basically saying, hey, I'm missing this header file. So let's just be good citizens and make sure that is in place. And actually, because this is one directory back, interactive actor. So there is our interface definition. It is now attached to our interactive prop class, and we can actually go ahead and now start implementing the details for it. And this is where it gets just a little bit kind of wonky, as we are forced to basically create the prototype declaration for our interface method. And the way you do that is you basically replicate the method definition that we have in our interface, and interact. And this U function definition doesn't necessarily have to be the same, but I'm just going to keep it consistent for now. And we're going to say void interact, and this ends up being this is our prototype declaration. So this method doesn't actually, doesn't do anything. In order to actually support it, we need to create an implementation version of this method. And to do that, you basically say virtual void interact underscore implementation. And then we override it. And this is the internal method signature that the engine is going to call as it processes the interface definitions through reflection. So let's just comment this implementation of our interact method. And this is the method that we're going to override in our CPP file for our interactive prop in order to, have it do some stuff. So let's go ahead and make our prop just a little bit more exciting, because right now it's kind of boring. So let's go ahead and add in, actually no, we're going to be a little bit lazy. We're going to grab the, not this guy. We're going to grab the static mesh component, this guy here, and we're just going to carry this over back to our interactive prop. And this is just so we can have something to actually operate on and showcase that things are actually changing when we call our interact. Okay, so we have our base mesh defined. That's okay. Now we're going to go ahead and flip over to the interactive prop CPP file and implement our method. So void a interactive prop, and we're going to say interact implementation, and there it is. So let's go ahead and also include just another property. So what I'm going to have this interact method actually do is just scale our base mesh object. So it's going to go from small to big and vice versa. And so it's going to be basically a little toggle. So we're going to say bool b is, let's say big. And oops, let's go back to our prop. And in here, we're going to say if I'm not big, then I want to say base mesh. Oh, and before we get too far, let's actually initialize this component. So base mesh equals create default subobject. Static mesh component, and we're going to give it the name of base mesh. So there's that guy, and then we're going to set him to be our root component. Great. Now the only other thing I'm going to do, because my autocomplete has a hairy canary if I don't actually define these component definitions. So there we go. And now we should be able to say, hey, for our base mesh, when we are interacting with this particular prop, we're going to set the scale, the world scale, to a new vector. So we're simply going to say our scale vector is going to go from whatever it currently is, which is, 1, 1, 1, to just 2. And we're going to say b is big equals true. Now on the flip side, we're just going to reverse this. And we're going to set this back to 1. So everything is nicely, explicitly defined. And we can even go a little bit further and throw in some debug messaging, but I think this is fairly straightforward that we don't really need to troubleshoot it too much just now. Okay, so there is our prop. We implemented our interface definition. Our interface is now kind of done its job. We don't really need to mess around with it too much. But we also need to make use of this interaction. So how do we do that? Well, in our player character, if you guys recall from one of our previous line trace tutorials, I have this method here, fire line trace, and what this does is it simply shoots out a line trace of a certain length, line trace distance. And in this case, I was using it to showcase how you can do like a shotgun spread, shooting from the camera, shooting from player head, and we're not really going to do that, but we're going to create a new method for interaction. And we're going to use this line trace logic to basically shoot from our player's face down to the object that we're facing at in order to trigger that interaction. So let's go ahead and implement that. So I'm just going to flip back to my header, and we're going to create a new function. And it's going to be called interact. And then we're going to just quickly flip over to its definition. And then what I'm going to do is I'm just going to start quasi-copying and pasting this particular logic. There's sort of enough meat and potatoes in this particular fire line trace that we can use it as a baseline. So we want our start vector, we want our end vector. We are also going to determine the position of the player's head. So we're going to say f vector player eyes lock, f rotator right, and we're going to get the actor's eyes point of view. This is where we pass in our player eyes location as well as our rotation. And that's going to fill up these two vectors. And then we're going to set the start of our line trace to be player eyes location, and the end to be the player eyes location, just the player eyes rot vector times our line trace distance. And as we notice, this is the same logic we have down here, just without all this extra spread and sort of camera logic implemented. Okay. Oh, sorry, this should be plus. So we have our start and end. Now we're going to set up our collision parameters. So to do that, we're going to create our collision query params. These are going to be our trace params. And this is going to be our interact trace. And what else do we want to do? So we want to say, yeah, let's make it a complex trace, and we're going to pass ourselves as the ignore parameter. Because we are shooting from the camera outwards, we want to just ignore the player in case there is any sort of collision. So I think we're okay with the trace parameters, and then we're going to create some hit result details. So interact hit, and there's our f hit result, and then we're just going to determine whether or not we actually hit something. So we're going to say B is hit. And we're going to cast a line trace going out from our world. We're going to use the single by channel call, which takes in our interact hit. It's also going to take in our start, our end, the collision channel that we're going to use, and I'm actually going to lift the one that we're using in our fire line trace. I'm going to take this guy, as well as our trace parameters. Excellent. So this is going to fire our line trace and determine whether or not we actually interact with something. Now, if we actually hit something, we want to do a little bit of logic. So first things first, I'm going to lift this little debug statement just so I can see, hey, we hit something, and I also want to see what did I hit. So we hit this guy, and sorry, this is going to be our interact hit. So this is the actor we hit, and we're going to draw a green line going out from the start to the end direction. Okay. So with this in place, we can now recompile and just make sure everything is up and running. So I'm going to do that, do a quick check, and then we'll go back to determining if we hit the proper actor with the proper interface and then execute that interact option on them. Okay, so everything's recompiled, and now let's go ahead and actually make sure everything's still operational. There's our guy, things are running. This is our fire line trace, but we don't actually have a button for interact. So why don't we go ahead and remap that real quick. So I'm just going to go back to the input down here, and we're going to change. We're going to change fire line trace to interact, and we'll leave it as F. So that's that, and actually, I did make just one little omission here. So we don't have a key binding for our interact call. So I'm just going to go ahead and throw that in and make sure our interact button is actually doing stuff. So we should see a line trace that's green if everything is working correctly and hits are occurring. All right, let's take a look now, and if we hit F, nothing is happening. We walk up to our cube and we hit it, and you can see there's our lovely line trace. Now, it's coming from the head of the player outwards. So obviously any sort of rotation, like I can shoot it from the back of his head. We're not going to worry about that too much. We can clean all that up in later tutorials where we actually have them rotate and sort of behave accordingly. But there's our line trace, and things are starting to come together. So let's go back to our C++ code and flip back to our interact method. So our line trace is working. We're actually hitting objects. Now let's determine if these objects are things we can interact with. So we have a couple different ways of going about that. Let's walk through a bunch of them. So we're going to do it using We're going to use it using implements interface. We're also going to do it using isA, which is a similar call to implements interface as well. We're also going to cast and determine null. So what do I mean by implements interface? Well, we're going to say if our hit actor, so we're going to say interact hit get actor get class, and there is a implements interface method on it. So into this, we're going to say, hey, do I implement this interface of view, enter, and before we do that, let's make sure we actually bring in our header file. I always forget about that. So there's an interactive prop. Let's go back to our slightly broken piece of code. And now we should be able to say, hey, do I implement an interface of you interactive actor? And there's our static class. Oops. So if I implement this interface, I can now do stuff with it. And the way you go about doing that is you actually end up calling the interface signature. So you say I interactive actor interact, and inside of that, oh, there's no parameters. Strange. You may also notice we have this execute interact, and this guy takes in a parameter, and he takes in a parameter of the object you want to execute this method on. So it's a little bit backwards from sort of our regular code definitions, where you end up having to pass in the actual actor against the interface definition, basically saying, execute this operation on this guy based on this interface. And if our check here passes, this thing is going to do something. So let's just recompile and see if we can get this guy actually doing stuff. Okay, so our project is recompiled. Let's go back to our game and let's see what this little cube is going to do for us when we hit it. And the answer is absolutely nothing, because it does not implement our interface. But never fear, we created this lovely interactive prop object. We're just going to tweak it a little bit to make sure it actually has a mesh that does something when we click on it. No, we don't want a pipe. Pipes are boring. Let's do a cone. Exciting. Okay, so if you guys can recall, our interact method on our interactive prop is just supposed to scale it from 1 to 2 and then back. So this cone is just going to grow a bit. Actually, the expected behavior is going to be this. So we're just going to lock these scales. 2, 1, 2, 1. This is what our interact method should do if everything is working correctly. So let's go ahead and drop this cone into our world. And now let's start interacting with it. Not working. And that might just be due to the collision that we have on this mesh. Let's just see here. If that's the case. There it is. Yeah. So as you can see, I fire my line trace. I determine if this is an interactive or interactable actor. And I execute, the method on it. Now, my logic is a little bit broken, and let's just see if we can determine why. Oh, because I'm not flipping this around. So, rather than doing this, why don't we just clean this up a little bit, and we're going to say there. That's going to flip-flop it a little bit better. Okay, so we're all recompiled. Let's go back to our project, and now big cone, little cone, big cone, little cone. So this isn't overly impressive, but the fact that we now have a generic interface with a method signature that you know, is going to do some stuff behind the scenes, we have a lot of power at our fingertips. So what we can do is we can go ahead and create this interact method now on pre-existing objects, and very quickly, I don't need to adjust any code in my player character. You know, I don't need to determine if it is a destructible prop versus an interactive prop. I check my interface and, you know, I go from there. But before we do that, let me just show you a couple of different ways of going about getting at the interface definition. So this is our using the implements interface call. Let's we're going to steal this bit, but let's comment out the rest of it. Oops. So we can use isA to basically determine the same logic. Oops. Interact hit. isA, and we're going to pass in our new interactive actor static class in again. So if this passes, we're going to execute our operation again. So let's recompile and just try that out. Okay, so we're all recompiled, and let's now try out the isA execution. And it doesn't work. I let you down a false sense of security. Just when you thought it was working, it's not. And the reason it's not working, because this bit me in the butt a couple of times, is this actually examines the class definition of the object as opposed to the interface. Remember when I said they were primarily used for reflection of the engine? So don't do this. This is going to give you bad times. But we do have a secondary way of getting at this information, and that is by doing a quick cast. And the way this plays out is we say I interactive actor equals, and we're going to cast it to our interactive actor. Hit get actor. And then we can simply say if our interactive actor is not null, then execute our method signature based on this interface definition. So let's recompile and just try that out, and I promise I will not trick you anymore. Okay, all recompiled, and let's double check this method. So there you go. If we cast it to our interface, determine if it's null, we can go back to our regular expected execution. Now, I don't necessarily like this method the most because we are doing a cast, which is just another, you know, extraneous operation, whereas here we're just doing a quick comparison on the interface definition. So I'll leave this guy in just so you guys have another example. But I'm going to bring this guy back just due to my own personal preferences. Deal with it. Okay, so we've gone ahead and introduced a new prop. We've made it do stuff. Now let's go ahead and add the same interface onto an existing prop. So we're going to take this destructible prop, and we're also going to make it slightly more interactive. Interactive actor, and we're going to say public interactive actor, and then very similar to other prop definition, we're going to say u function. Actually, you know what? I'm not even going to type this out. We are just going to copy and paste that because we are lazy developers. So we're going to grab this, and we're going to pop it back right over to our destructible prop. And then we're just going to go ahead and specify the implementation. So what do we want this guy to do? Well, we're going to have him basically get destroyed on interaction. So somewhere here we have our trigger destroy method. So we're simply going to say trigger destroy. Pretty simple. One thing I'm going to do is I'm just going to comment out the overlap logic for this particular prop, because right now if we step into its boundaries, it's going to cause the various overlays or overlaps, and things are going to go wonky. We're also going to take off the component hit, and we're not going to do any damage with it, just for sake of presentation. So there's our trigger deploy, interact implementation. I'm going to recompile. We'll drop one of these destructible props into the world and test it out. Okay, so we have our destructible prop all set up. Let's go ahead and now drop this guy in, and you know, I'll do the rock. We'll do a couple of these guys. Oh no. Oh no. Where'd that go? Come back, you. Oh man, my angle's all messed up. Hold on a second. And there's another rock. Go. So, our cone, bigger, smaller, still works. And now, look at that. Laser vision. I just look at these rocks and they fall apart. So there you go. Look at that. Very quickly we were able to modify existing objects within our game to include additional functionality. We had almost no additional interaction with our player character. We were simply just adding another object with the same interface through the same piece of logic. And you know, you can now have the power of basically doing, well, you know, kind of whatever it is you want with these types of interfaces. Lots of different bits of logic can be applied. Right? You can see, you know, you can have now a number of different set pieces that perform in different ways while our actor is executing, or our player is executing, the same bit of logic on them. Right? So this is how a lot of games do their interactions with doors and objects and all this wonderful stuff. So you only have to hit one button and magic things happen. So thank you for tuning in, and I hope to see you guys next time.